Welcome to Electrical Machine 1 lecture. Today's topic is auto transformer. Auto transformer. Okay. So in the previous lecture, uh, it is discussed just a minute. Auto transformer. So in previous lecture, a three-phase transformer, their connection and their calculation has been discussed. One more points in the last lecture we have discussed that all-day efficiency of three-phase transformer. So the evaluation of a three-phase transformer, especially distribution transformer, is viewed with the help of all-day efficiency, and it is a better representation instead of simply calculating efficiency at different load condition. So to check the performance, the best way is the all-day efficiency of three-phase transformer. Okay, so this is up to the last lecture. Today we are going to discuss the auto transformer. Auto transformer is a single winding transformer. It is a it is a single winding transformer. In the previous discussion in the single phase transformer, there are two windings. One is the primary winding and the second is the secondary winding. It may be written as a LV winding and HV winding. These two windings are magnetically coupled to each other, whereas electrically isolated. Means there is no electrical connection between winding A and B, but it is magnetically coupled. So whatever the power is going to transfer with the transformer action or induction process, and we will get the some secondary power as soon as it is connected with the load, and primary is connected with the source, AC source. So this is the two winding transformer, whereas auto transformer is a single winding transformer. It is going to work as a step up transformer, step down transformer. Okay, it work as a step up transformer, which is depend upon the number of turns in the primary winding and secondary winding. If the number of turns in the primary winding is N1, number of turns in the secondary winding is N2. If N1 for step down, the N2 is smaller than N1, and here the step this is both are step down. It is a step up transformer, and for the step up transformer, the number of turns in the secondary winding is greater than the number of turns in the primary winding. So this two winding transformer provide the upper means it provides the change in voltage in the secondary terminal either more than the primary voltage and lower than the primary voltage. Whereas the KVA rating of primary winding and secondary winding will remain same. So KVA of winding A and KVA of winding B is equal. So this is equal, isn't it? And hence we can say that on the HV side, the current is smaller. On LV side, the current is higher one. So this is something, this is the same for the two winding transformer. Whereas in the single winding transformer, there is a single winding on the one side, whereas the winding is connected, the winding primary winding primary winding is connected with the source. There is only single winding. It is connected with the source. Okay. And secondary winding, one terminal is common, and secondary winding is connected to the ohmic contact with the somewhere in the turns. So if this is represented as, this is the winding which is connected with the source, total winding which is connected with the source, and secondary terminal is connected with the, maybe there is a tap, or maybe there is some physical contact or ohmic contact is there. So this is the voltage V2, this is the voltage V1. So this is the source is connected over here, source is connected over here, and on the second side the load is connected. So now it works as a step down transformer. So it is a step down auto transformer. Auto transformer. Step down transformer, the meaning is that here the voltage V1 is greater than voltage V2. So voltage across load is smaller than the voltage across source. So it is a step down transformer. So here is a ohmic contact. Now, if you want some different voltage level, we can provide a second tap over here. Okay, we can provide tap here. Say this is the voltage V21. Say this voltage is V22. Okay, V22, and so on, V23, and it may be less than. So here, by this arrangement, we can obtain the secondary voltage in different voltage level for the different applications. Say, for example, it is a 230 volt supply, and here the voltage is given as a 15 volt, one, second is 12 volt, and third is say 6 volt. So now it is possible with the help of a single winding transformer with a different voltage level. Okay, now it also possible that instead of getting the voltage across the secondary in step, say 6 volt, 12 volt, 15 volt, we can obtain 6 volt, 7 volt, 8 volt, 9 volt, and so on. So for this purpose, under such condition, the construction, say for example, this is the circular core is there, and from this circular core, so this is the winding which is connected with the source. This winding is connected with the source. So this is the voltage V1, and the secondary voltage, this terminal is common for the secondary side, and instead of tapping, we can provide a continuous change in the voltage with the help of some variable contacts are there. So this is the variable contact. It represents the variable contact over this one. So by varying this one, changing this position of the handle either in this direction or in this direction, now voltage V2 is a vary with respect to the change in position like this one. So it can be represented as this is the primary voltage, the primary winding means the source which is connected to the source. This is connected with the source, AC source, say voltage is V1. Okay, and whereas the secondary winding, it is a variable point is there. So this represent the variable point. So this may vary as per the requirement. So it is called as a auto transformer. It is a variac because it can vary the voltage with start from 0 to say the rated voltage up to this one is 230. So either voltage from 0, 10 volt, 20 volt, 30 volt, and so on, we can opt in. So this is the single winding transformer, and it is a step down transformer. Similarly, for the three phase, the same case is there. Only the in the primary side or the source is connected with the three separate windings. It is connected in say star. Say for example, this is one winding, second winding, for second phase and for three phase, third winding. Now all these are connected in the together to form a star connection on the primary side. So it is a R, Y, B, and whereas the power is taken from say this is the variable points, it is a secondary voltage. So this voltage is V1, and whereas on this three terminal, the secondary voltage is V2. So the auto transformer is possible in a three phase as well as single phase transformer. Okay. Now this is the step down transformer. Can we go for the step up transformer? Yes, we can go for the step up transformer. In step up transformer, say this is the winding. The large number of turns across the load, So this is load over there, and source is connected to part of the winding. Say this is V1, voltage is V1, and this voltage is V2. So here it is a step up auto transformer. Step up auto transformer. It means that the single phase auto transformer as well as three phase auto transformer are available in step up configuration as well as step down configuration. Now, by looking this figure, one may say that it is similar to the voltage divider circuit. Voltage divider circuit, say this is the voltage divider circuit. It is a voltage divider circuit is comprises of like that. This is the source voltage, and this is the resistance. This is different resistances are there. Okay, and the second voltage is V2 is here. Say this is the current is I. It is capital V1. So V2 is equal to, which is equal to V upon total resistance, V1 upon resistance, total resistance is R, and the resistance across terminal is R2. So multiplied by R2 is the voltage across the second terminal. So this circuit and this circuit is quite similar. So one may say that auto transformer is similar to the voltage divider circuit, but it is not so. The reason is say in auto transformer, and this is the voltage divider circuit. Voltage divider circuit. So what is the auto transformer? Auto transformer coil, winding, single winding. And here the secondary terminal is taken from the common terminal and one ohmic resistor, one ohmic contact. So this is voltage V2, this is voltage say V1, number of turns in this section is N2, number of turns in total section say it is N1, where it is say terminal is A, B, C. So the number of turns N, A, C is equal to say N1. Number of turns N, A, B, NAB we will write first. Next, what is the number of turns in B to C? So NBC is equal to N2. So in this section, NAB is equal to N1 minus N2. This is the number of turns are there. So under such condition, the V2 is equal to V1 upon N1. It is the turns per ratio, turns voltage per turns multiplied by a number of turns in the voltage across N2. So it is N2, where V1 upon N1 is the voltage per turns. Voltage per turns, isn't it? So this is the voltage at auto transformer circuit. Whereas voltage divider circuit, so there is a number of resistances are there, and so on. So this is the voltage is V. Resistance is R1, R2, R3, R4. Let the voltage is taken from R4 is V2. This is V1. What is the voltage V2? V2 is equal to voltage impressed divided by total resistance R1 plus R2 plus R3 plus R4 multiplied by R. Okay, so this is the voltage we are getting with the help of voltage divider circuit. So these two circuits are similar? No, the circuit it is getting some voltages down. So voltage down is possible with the help of voltage divider circuit, whereas in auto transformer, a step up voltage is also possible. Is possible, but here not possible. So in voltage divider circuit, voltage step up is not possible. Only it is used for step down voltage. In the case of auto transformer, the losses in the copper losses, say it is the ohmic loss, I square R loss is small. At the same time, here the ohmic loss is very high because the current is constant. Here the current is constant, whereas the current in the primary side or I1, it is depend upon the load condition. Whereas it is just simply it is connected across the source. So continuous, there is a continuous source, there is a constant value of current. Here the current is depend upon the load condition. If the load on the secondary of the transformer is zero, only magnetizing current is needed, whereas load is connected, the primary current is depend upon the load current, and hence it is say variable to the square losses, whereas here the constant I square R loss is there, isn't it? Second, with the help of say here the second point is ohmic loss. Ohmic loss, instead of we can say that power loss is small and depends on load, whereas the high power loss or higher power loss and constant irrespective of and irrespective of load condition. Okay. Now the third point is that here the step up, okay, it's have been taken. Second is next step, next advantage is say one more advantage we can search out. Okay, so these are the say advantage of auto transformer over a voltage divider circuit, isn't it? So this is some basic idea we are taking, understanding what is the difference between voltage divider circuit and auto transformer. So we cannot say that auto transformer is just similar to the voltage divider circuit, because in voltage divider circuit, voltage step up is not possible, the power loss is higher, and the continuous power loss is going to take place in the resistance RL. Now we will start some discussion with the auto transformer, step up, step down auto transformer. Step down auto transformer. Step down auto transformer, first draw the circuit very carefully, because in the auto transformer we may confuse so voltage in this side is V1, okay, terminal A, B, C. So the number of turns here, it is N1. Voltage number of turns between terminal B and C, it is voltage is V2, and number of turns is say N2. Okay, so we'll write as number of turns N AC is equal to N1. Number of turns between BC is equal to N2, and number of turns AB is equal to N1 minus N2. So here the number of turns is N1 minus N2. Okay. N1 minus N2. Now represent the current. The current in the primary winding, number of is say I1, and the current delivered to the load is say I2. Current delivered to the load is I2. So under such condition, the current in this part, up to this part, is the difference of I1 minus I2. If you apply the KCL at point B, Kirchhoff current law, so this current is equal to I2 minus I1. One may write as I1 minus I2, but it is wrong. The wrong reason is that here it is a low voltage circuit, and here it is a high voltage circuit. It is a step down transformer. So definitely the winding which has a low number of turns, or LV winding, the current in the LV winding is more, and current in the HV winding will be smaller. So higher current minus lower, isn't it? So it is just simple. Now similarly, the voltage across, the voltages depend upon the number of turns. So under such condition, the voltage up to A to B is equal to V1 minus V2. Okay, just again I will repeat, this is a step down auto transformer. It's a single winding transformer. The winding is single. Part of the winding is common for the primary side as well as the secondary side, and it is a ohmic contact we have taken for the point B. So the number of turns, total number of turns is N1. So it is written as NAC is equal to N1. Number of turns across the secondary terminal or load terminal is NBC, which is equal to N2. So definitely the number of turns remaining is equal to N1 minus N2. Okay. So up to this one, it is N1 minus N2. It is V1 minus V2, because depend upon the number of voltage is depend upon number of turns are there. Similarly, current, low voltage winding current is more. So I2 minus I1, it is here by taken. Okay. So what is the voltage across load circuit? voltage across load circuit. Therefore, V2 is equal to voltage per turns for the primary side V1 upon N1, V1 upon N1 multiplied by N1 multiplied by N2 is the voltage across this one. Okay. Now we will examine the say voltage balance, MMF balance in the say primary winding and secondary winding. Okay. Now remember that this is the say in the one direction. The notation or polarity has been shown. They are in the same direction. Okay. Now the MMF across AB should be equal to MMF across BC. Okay. MMF across winding AB. क्या हो जाएगा? number of MMF across AB is equal to current I1. So here we'll write as a MMF just a minute. Yeah, MMF balance, no need. So we will write as a MMF balance. Okay, only MMF balance. We are going to examine the MMF balance. So MMF across winding AB is equal to MMF across winding B to C. Okay, so here I1, current I1 flowing between A to B is I1 into bracket N1 minus N2 is equal to current flowing in this terminal B to C is I2 minus I1 multiplied by N2. So here, therefore, it is I1 N1 minus N1 minus I1 N2 is equal to I2 N2 minus I1 N2. So this minus N1 I2, sorry, I1 N2 and I1 N2 get cancelled, and therefore MMF in the primary winding or winding at A to B N1 is equal to I2. So the MMF balance is there in the equation. Okay. Now we will take the step up transformer. In a step up transformer, the number of turns, it is auto transformer. Okay. So here we have proved that the MMF balance. So when MMF balance is there, the flux is also constant. So is V1, current is it is A B, C. Let the current in the secondary terminal is I2. Current here, it is a primary winding, is I1 from the source. So here the current I2 is smaller because it is on the HV side. So it is I1 minus I2. Okay. Now the number of here the voltage here the number of turns is say N2 minus N1. So definitely it is V2 minus V up to this point. And here the number of turns is N2. Okay. Now we will check the MMF balance. So MMF balance A to B is equal to B to C, isn't it? So here it is, can we write it is a N2 or it is for that balance, what we will write, what should be the value? Sorry, this is it is wrong. Here it is total number of turns is N2. It is correct. Here it is wrong. It is N1. Okay. It is N1. So therefore, under such condition, N1 into bracket I1 minus I2. Okay. N1 A to B, B to C, N1 I1 minus I2 is equal to current I2 on the secondary side, that is the HV side, N2 minus N1, N2 minus N1. So by opening this bracket, N1 I1 minus N1 I2 equal to I2 N2 minus N1 I2. So again, these two similar terms get cancelled, and remaining term is N1 I1 is equal to N2 I2. It is quite similar to the step down transformer. So here the MMF balance either by the step up and step down, both in the both cases it is quite same. Okay, so this is somewhat about the auto transformer basic idea of the auto transformer. Now say what is the similarity between the two winding auto transformer and single winding auto transformer? We'll just say we can have a step down transformer. Again, we'll take the step down transformer. Step down auto transformer. What is the step down auto transformer? Here there's a turns are there. Say this is divided into the two windings. Winding step down. Okay, so it is a step down transformer. It is a V1. Number of turns, total number of turns is N1. Here the secondary terminal load side, it is V2. Number of turns is say N2, A, B, C. The number of turns here, it is N2 minus N1. Similarly, the voltage, it is V2 minus V1 in this side. The current is I1, current is I2, okay? And here the current is I2 minus I1. Okay, this is the step down auto transformer or single winding transformer, is it? We can represent these two windings in such a way that this is the one winding. This is second winding. So it become a two winding transformer. Now we will give the names. This is terminal A. This terminal is B. So this again it is B terminal and this is C terminals. Just it is separate out in this two one. Voltage across A to B. A to B. What is voltage across A to B? This is N2 minus N1 or V2 minus. So this is across it means that the voltage across this one is equal to the V2 minus V1. Okay. Whereas the current is I1. Current is it is I1. Now in the second side, this part, the current is I2. This current is I2 and the voltage is V2. Voltage is V2. What about current? Current is I2 minus I1. Okay. So this is the circuit. Single winding auto transformer is converted into the two winding transformer, our single phase transformer. No doubt here the voltage applied is not only V1, but it is the difference of V2 minus V1. Similarly, in the secondary, current is I2 minus I1. This is not I2 here. It is I2 minus I1. Okay. So it is just similar. If you just forget this value I2 minus I1, V2 minus V1. So it is similar to the two winding transformer. So definitely the we can say that equivalent circuit is possible. Okay. So this equivalent circuit, it is for the excitation component is there. Resistance, equivalent resistance refer to the primary side or refer to the secondary side. Again, it is possible. So here, this is the equivalent circuit. We are not going inside the calculation of reactive component, that is the exciting component and core loss component. So it is X0 as usual. This is R0. This is R, say primary side, resistance refer to the primary side. Resistance, reactance refer to the primary side. This is voltage V2. This is voltage V1. Okay. So it is means equivalent circuit is also possible for the auto transformer for examine its performance and all these things. So this is the some basic of auto transformer. Auto transformer, no doubt, it contains many calculations. There is a comparison between single winding auto transformer and two winding auto transformer. And really, it is very interesting. In the next time, we will see the comparison. First we'll see the points as a rating of auto transformer. Okay, and all these things. Say only we will see the application of auto transformer is that where to boost the voltage. Say let this is the source supply, and it is a very long transmission line is there. We want 11 kV voltage is going to impress at the sending end, and we want the voltage at the receiving end is equal to the 11 kV, but there is some voltage drop across this one. To compensate that voltage drop, we may use this auto transformer as a booster transformer. This is one application. It is used in the practical application in the labs to change the voltage for to conduct the different practicals. So as a variac, where the smooth change in the voltage is possible on the secondary side. This is the one more application. It is used in some control circuit, but no doubt it cannot be used as a continuous operation because the per unit reactance of the winding is small, hence the short circuit current is very high. It is higher. So if there is a short circuit, the short circuit current magnitude is very high as compared to the two winding transformer. These are the some points to be considered. Now, especially we will consider the rating of the transformer. It has a two type of rating. One is the induction rating, that is the transformer action. The second is the conduction action. So see here, either it is a step up transformer, a step down transformer. The winding, the load is connected to the secondary terminal here. So this is the electrical connection. So we can say that the voltage multiplied by the current, voltage multiplied by the current is the conduction over here. And second, this winding is common, so there is an induction process. So there is a two type of KVA ratings. So in the KVA rating is equal to KVA transform by the transformer action plus KVA conduction. KVA conduction. So there's a two ratings are there: transformer action rating and conduction rating. Okay, thank you. For next time, we'll see the these points in the auto transformer.